Okay, here's another question. 1 on x. 1 on x is greater than or equal to 2. Now, this looks really pretty straightforward. If this was an equation, it would be easy. It looks quite innocuous. However, there is a little sting in the tail here that is quite subtle and would be easy to miss. It all comes back to that property of inequalities that if you multiply it through by a negative number, the sign changes. All right, now if we were solving this, what we would do is we generally multiply by the denominator, and that would help get x off the bottom and make things easier. All right, but here is the issue. We don't know whether x is positive or negative, right? If x was negative and we multiplied through by x, well, that would change the sign of the inequality. If x was positive, it wouldn't matter, but we don't know. We don't know whether x is negative or x is positive. And so that is a problem. That's a dilemma. What do we do? All right, so the way we approach this is rather than multiplying through by x, which generates this confusion, we're not sure whether x is positive or negative, we multiply through by something that we know is positive. Okay, so rather than multiply through by x, I'm going to multiply both sides by x squared. Now, multiplying by x squared is really safe because we know that whenever we square something, the result is positive. Okay, so x squared is positive, and that means that the sign isn't going to change when I multiply through. So I'll multiply both sides by x squared. On the left, that's going to give me x squared on x, which is just x. And on the right-hand side, I'm going to get 2x squared. Okay, so now I can sort of go about this in the, like a quadratic inequality. What I'll do is I'll just, I might just swap that around. So I'm going to get 2x squared is less than or equal to x. I've just flipped it. I'll take the x across to give me 2x squared minus x is less than or equal to 0. Okay, factorising gives me x outside of 2x minus 1 is less than or equal to 0. And now we go about that technique that we use for quadratic inequalities, which is look for where this is equal to 0. So looking at that left-hand side, I can see that that will equal 0 at x equals 0 and x equals a half. And so I will draw a number line. And I'm going to put on it x is 0, x is a half. And I'll test a region. Okay, so let's test one to the right of x equals a half. So I might as well try x equals 1. When I put in x equals 1, I'm going to get 1 times 2 times 1 minus 1, which will just be 2 minus 1. And that is 1 times 1, that's greater than 0. So that is no good. All right, so all this region here, no good. All right, let's test the other region down the other end, less than 0. So I'll put in minus 1, and I'll get minus 1 times 2 times minus 1 is minus 2, minus 2 minus 1. And that gives me what? Minus 1 times minus 3, which is positive 3. That's greater than 0. So again, that's no good. That region, everything to the left of 0, doesn't work. That leaves me with one region only, which I'm assuming is going to work, but let's test it. What will I put in? Let's put in x as a quarter, halfway. So a quarter is going to give me, okay, a quarter times 2 times a quarter is a half minus 1. So I get a quarter times negative a half. That'll give me negative 1/8, and that is less than 0. So that's the region I'm after. Right here, everything in between 0 and a half. Now, there's one other little sting in the tail that we need to be careful of. I know x is less than a half, less than or equal to a half, sorry, because our inequality is including equality. So my solution for x is everything is x is less than a half, less than or equal to a half, would I say greater than or equal to 0? Okay, now ordinarily I would, but I have to be careful here. I have to be careful. Can x be 0? Look back at the initial inequality. 1 on x is greater than or equal to 2. Now, if we include x equals 0 in our solution, look at what we get on the left-hand side. When I substitute in 0, I'm going to get 1 over 0. That's not allowed. I can't have 1 over 0, and so I can't include 0 in our solution set. Okay, so I'm not going to. It's not going to be greater than or equal to 0. It's just going to be greater than 0. So that's quite subtle but important to be aware of. I'm not including 0 because that clearly doesn't make sense. Okay, x can't be 0. All right, so there's our final solution set. X is greater than 0 and less than or equal to a half.